Today we are going to learn about remainder and factor theorem. We're also going to solve cubic equations. This is grade 12 calculus. Now it's lesson 3 of 6. So before we can start with remainder and factor theorem, let's look at what we learned in primary. Okay, so the four parts of a division. If you have 31 divided by 9, this is equal to, normally this is what you are going to do. Okay, you are going to do this. So you have 31 divided by 9. Okay, how many times 9 goes into 31? 9 goes into 31 3 times. Okay, so you have 3 there. 3 times 9, 27. Okay, now 31 minus 27, you have 4. So this is what you do. Now the four parts of a division, you have 31, which is the dividend, right? 31 is the dividend, and 9 is the divisor, 3 is the quotient, and 4 is the remainder. Now the dividend is the number that is being divided. In this case, 31 is divided by 9. Okay, so the dividend is 31, and the divisor is a number which divides another number. In this case, 9 divides 31, and the quotient is the number we obtain when we divide one number by another. Or you can say a quotient is the result or the answer of the division of a number by another number. Okay, and the remainder is the amount left over after performing a division. So with this, you know that the dividend is equal to the quotient multiplied by the divisor plus the remainder. Okay, so the dividend in this case is 31. So 31 is equal to the quotient. The quotient is 3. 3 times the divisor. The divisor is 9 plus the remainder. The remainder is 4. Okay, plus 4. So 31 is equal to 3 times 9 plus 4. Okay, so 3 times 9 is 27. 27 plus 4 is 31. This is always the case. Okay, now let's move on to remainder and factor theorem. I'm going to try to explain this the simplest way. Okay, let's say you are given f of x is equal to this. Okay, f of x is equal to this. Now, the remainder, f of any x value is going to be the remainder. Okay, so example, when you take f of 2, you're going to plug 2 in there. This is going to make sense as we move. Okay, f of 2 is equal to, you're going to plug 2 wherever you see x. Okay, so you have 2 to the power of 3 minus 4 times 2 to the power of 2 plus 2 plus 6. Okay, you plug 2 wherever you have x. So this is equal to, when you plug this in your calculator, let me use my emulator. I have 2 to the power of 3 minus 4 times 2 to the power of 2 plus 2, and then plus 6. Okay, this is equal to 0. So now it means the remainder is equal to f of 2, and this is equal to 0. So the remainder is equal to f of 2, and this is equal to 0. So this tells you that if you divide f of x by x minus 2, okay, when you take this in there, the sign is going to change. Okay, you're going to have minus 2. Okay, this tells you that if you divide f of x by x minus 2, the remainder is 0. Okay, as you have obtained it. Okay, this tells you that if you divide f of x, this is f of x. If you divide f of x by x minus 2, the remainder is 0. And because the remainder is 0, now you have a factor. Okay, because the remainder is 0, now x minus 2 is a factor of f of x. Okay, let's look at another example. Okay, example. Remember again, f of any x value is the remainder. Any value that you plug in there, you are going to get the remainder. Now, let's use negative 2. Okay, you can use any x value. Let's use negative 2. Okay, so f of negative 2, this is equal to, you are going to plug negative 2 wherever you have x. So this is equal to, you have negative 2 to the power of 3 minus 4 times negative 2 to the power of 2 plus negative 2 plus 6 is equal to you have negative 2 to the power of 3 minus 4 times negative 2 to the power of 2 plus negative 2 plus 6. This is equal to negative 20. Okay, negative 20. You can see that. So, the remainder is equal to f of negative 2. This is equal to negative 20. Okay, this tells you that if you divide f of x by x plus 2, remember, you change the sign. If you divide f of x by x plus 2, the remainder is negative 20. X plus 2 is not a factor of f of x because the remainder is not equal to 0. Okay, you are going to have a factor only when the remainder is equal to 0. You are going to have a factor. Okay, the remainder is equal to negative 20. Okay, now let's move on. We are going to solve problem on remainder theorem. Use the remainder theorem to determine the remainder when f of x is equal to this is divided by a, x plus 4, b, x minus 2, c, 2x plus 1, and d, 2x minus 5. So solution, let's start with question A. Okay, use the remainder theorem to determine the remainder when f of x is equal to this is divided by x plus 4. Okay, so you are going to plug negative 4 to get your remainder. Okay, so plug x is equal to negative 4 into f of x, and then you can get your remainder. Okay, so you are going to take f of negative 4 is equal to, you are going to plug negative 4 wherever you have x. So you have 4 times negative 4 to the power of 3 minus 8 times negative 4 to the power of 2 plus negative 4 plus 2. This is equal to, you are going to plug this in your calculator, okay, to get the remainder. Okay, so you have 4 times negative 4 to the power of 3 minus 8 times negative 4 to the power of 2 negative 4 to the power of 2 plus negative 4 plus 2. This is equal to negative 386. Okay, negative 386. Negative 386. So, the remainder is equal to f of negative 4. This is equal to negative 386. Okay, so it means if you take this f of x, you divide by x plus 4, what? will be left will be negative 386. Okay, if you divide this f of x by this x plus 4, the remainder, what will be left over, will be negative 386. Okay, now question B. Use the remainder theorem to determine the remainder when f of x is divided by x minus 2. Okay, you are going to plug x is equal to 2 into f of x to get the remainder. So you are going to take f of 2. This is equal to 4 times 2 to the power of 3. So you plug 2 wherever you have x. You carry on, you have negative 8 times 2 to the power of 2 plus 2 plus 2 again, right? The remainder is equal to, let's use our calculator again. So this is my emulator. You can use your calculator. So you have 4 times 2 to the power of 3 minus 8 times 2 to the power of 2 plus 2 and plus 2 again. This is equal to 4. So the remainder is equal to f of 2. This is equal to 4. Okay, it means if you divide f of x, this f of x, by x minus 2, you are going to get 4. Okay, 4 will be what will be left over. Okay, the remainder of this divided by this is going to be 4. Okay, now question C. You have used the remainder theorem to determine the remainder when f of x is divided by this. Okay, when f of x is divided by this, what will be the remainder? You are going to plug x is equal to negative 1 over 2. Okay, so you are going to plug x is equal to negative 1 over 2. Okay, negative 1 over 2. You are going to plug x is equal to negative 1 over 2 into f of x to get the remainder. Okay, so f of negative 1 over 2 is equal to, you are going to plug negative 1 over 2 wherever you have x. Okay, so you have 4 times negative 1 over 2 to the power of 3 minus 8 times negative 1 over 2 to the power of 2 plus x. So you have plus negative 1 over 2 and then plus 2. The remainder is equal to, plug this in your calculator. Let me use my emulator. So I have 4 and in bracket negative 1 over 2 to the power of 3 minus 8 times in bracket negative 1 over 2 to the power of 2 and then plus negative 1 over 2 and then plus 2. This is equal to negative 1. Okay, negative 1 is the remainder. So this means if you divide this f of x, if you divide f of x by this, the remainder is equal to f of negative 1 over 2, which is negative 1. Okay, now question D. Use the remainder theorem to determine the remainder when f of x is divided by 2x minus 5. Okay, you are going to plug x is equal to 5 over 2. Okay, 5 over 2. So plug x is equal to 5 over 2 into f of x to get the remainder. Okay, f of 5 over 2 is equal to 4 times x cubed. 4 times x is 5 over 2 cubed minus 8 times x to the power of 2. X is 5 over 2, right, to the power of 2, plus x is 5 over 2, plus 2. This is equal to, when you plug this in your calculator, you are going to get 17. Okay, when you plug this in your calculator, you are going to get 17. So the remainder is equal to f of 5 over 2. This is equal to 17. This means that if you take f of x, this you divide by 2x minus 5, you are going to have 17. So 17 is the remainder. Okay, now let's solve problems on factor theorem. Okay, let's solve problems on factor theorem. Question 1. If x plus 2 is a factor of f of x is equal to this, determine the value of p. Okay, if x plus 2 is a factor of f of x is equal to 3x cubed plus px squared minus 2x plus 8, determine the value of p. Okay, solution. Since x plus 2 is a factor of f of x, right? Since x plus 2 is a factor of f of x, you know that if you plug negative 2 in this f of x, you're going to get 0. Remember from the previous slide, if you plug negative 2 in there, you're going to get 0. Since x plus 2 is a factor of f of x, if you plug negative 2 in there, you must get 0. Okay, so f of negative 2 is equal to 3 times x cubed. X is negative 2 plus p times x squared. X is negative 2 minus 2x. X is negative 2 plus 8. This is equal to 0, since x plus 2 is a factor of f of x. This must be equal to 0, since x plus 2 is a factor of f of x. Okay, now you have this. You are going to solve for p. Okay, so you have 3 times negative 8, which is negative 24. Okay, plus you have negative 2 to the power of 2. This is 4p plus 4p. You have plus 4, right? Negative times negative, it's plus 4, and then plus 8. This is equal to 0. So you are going to have 4p on its own. This is equal to, this is 12, right? 12 minus 24. You are going to have minus 12. You take it to the right, you have a positive 12. You are going to divide by 4 on both sides so that you can solve for p. You divide by 4, you have p is equal to, you divide by 4, you have 3. Okay, so p is equal to 3. Let's move on to the next question on factor theorem. Okay, question 2. Show that x plus 4 is a factor of f of x is equal to this. Okay, show that x plus 4 is a factor of f of x is equal to 2x cubed plus 9x squared plus 3x minus 4. Solution. You're going to plug negative 4 in there and see if you can get 0, because you are trying to prove that x plus 4 is a factor. Okay, when you have a factor, it means that the remainder is equal to 0. So you are going to plug negative 4 in there and see if you can get 0. Okay, so you are going to take f of negative 4. Okay, you are going to plug negative 4 wherever you have x and see if you can get 0 as your remainder. if you get 0 as your remainder, it means x plus 4 is a factor of this f of x. Okay, so take f of negative 4. This is equal to 2 times x cubed. X is negative 4. You have to the power of 3 plus 9 x squared. X is negative 4 to the power of 2, right, squared, plus 3x. X is negative 4, and then you have minus 4, okay, or negative 4. This is equal to, plug this in your calculator. I'm going to use my emulator. So I have 2 times, in bracket, negative 4 to the power of 3 plus 9 times negative 4 to the power of 2 plus 3 in bracket negative 4, then minus 4. This is equal to 0. Okay, you can see that. So, since the remainder is equal to f of negative 4, and this is equal to 0, okay, since the remainder is equal to 0, then x plus 4 is a factor of f of x. Okay, f of x is equal to this, right? What you have there. Okay, now question 3. What must be added to 2x cubed minus 5x squared minus 12x minus 4 so that it is exactly divisible by 2x plus 1? What must be added to 2x cubed minus 5x squared minus 12x minus 4 so that it is exactly divisible by 2x plus 1? Okay, let me simplify this question for you. Exactly divisible means the remainder is equal to 0. You have to get a number that is going to be added to this in such a way that this is now a factor. Okay, so let's solve this question. Solution, you are going to plug x is equal to negative 1 over 2. Plug x is equal to negative 1 over 2, right, into this. This is your f of x, right? Plug x is equal to negative 1 over 2 into this and see if you get 0. Obviously, you are not going to get 0 because they want you to add a number first in such a way that you get 0. Exactly divisible means the remainder is 0. Okay, so you are going to plug negative 1 over 2 into this and see what you are going to get. And from that, you are going to add a number so that you get 0. Okay, so if you get 0, it means 2x cubed minus 5x squared minus 12x minus 4 is exactly divisible by 2x plus 1. Okay, so you are not going to get 0. You are going to get a certain number. From that number, you will know which number you need to add so that you have 0. Okay, so you have 2 times this to the power of 3 minus 5 times this to the power of 2. This is your x, negative 1 over 2, right? Negative 1 over 2. You plug it wherever you have x. Okay, let's carry on. Minus 12 times this minus 4. This is equal to, let's plug this in our calculator. I'm going to use my emulator. So I have 2 times negative 1 over 2 to the power of 3 minus 5 times negative 1 over 2 to the power of 2 minus 12 times negative 1 over 2 minus 4. This is equal to 1 over 2. Okay? 1 over 2. You can see that 1 over 2. Now, from this, what do you have to add so that you get 0? Okay? So you have 1 over 2. Okay? So not exactly divisible by 2x plus 1 because you have this. This is not 0. It's going to be exactly divisible by this only when you have 0. Okay, so what must be added to this? You need to add negative 1 over 2 because when you add the two numbers, you are going to get 0. Okay, so you need to add negative 1 over 2 to get 0 so that it is exactly divisible by 2x plus 1. So this is how you can solve this question. Let's move on. Now we are going to see question 4. Determine the value of a and b if x to the power of 2 plus x minus 2 is a factor of this. Okay, determine the value of a and b if x squared plus x minus 2 is a factor of x cubed plus ax squared plus 2x plus b. So solution, this is your f of x, right? This is your f of x. F of x is equal to this, x cubed plus ax squared plus 2x plus b. Okay, this is your f of x. You need to factorize this. You have to factorize this so that you know what you need to plug in there. Okay, so you have x squared plus x minus 2. When you factorize this, you're going to have this. You have x squared, you're going to have x times x. You have negative 2, you're going to have 1 and 2. So you are going to have negative there and plus there. When you factorize, okay, you have to factorize this so that you can see what you are going to need to plug into f of x. So you are going to plug 1 and negative 2 into there. So we have two unknowns. Okay, we have two unknowns, a and b. Because we have two unknowns, we are going to create two equations. Okay, we need to create at least two equations so that we can solve for the two unknowns. Okay, we need to create at least two equations so that we can solve for the two unknowns. Okay, let's create our first equation. So we are going to plug 1 to create our first equation, and we are going to plug negative 2 to create our second equation. So we have f of 1, right? F of 1 is equal to, you plug 1 wherever you have x. So you have 1 to the power of 3, right? You plug 1 wherever you have x. Okay, you have 1 to the power of 3 plus a times 1 to the power of 2 plus 2 times 1 plus b. This is equal to 0 because you have a factor. So the remainder is equal to 0. Remember from the previous slide. We carry on. This is equal to 1 plus 1 times a. It's a plus 2 plus b. This is equal to 0. Okay, so you have 1 plus 2, which is 3, plus a plus b. This is equal to 0. So this is our first equation. Okay, let's create our second equation. We are going to plug negative 2, right? So you have f of negative 2. This is equal to, you are going to plug negative 2 wherever you have x. So you have negative 2 to the power of 3 plus a times negative 2 to the power of 2 plus 2x. X is negative 2 plus b. This is equal to 0 because this is a factor of this. Okay, this is a factor of this. You have it there. So this is a factor of this. And so you have the remainder is equal to 0. Okay, let's carry on. You have negative 2 to the power of 3, which is negative 8. You have this is 4 times a, so you have plus 4a. This is negative 4 plus b equal to 0. Okay. So you have negative 8, negative 4, right? Negative 8 minus 4, negative 12. 4a plus b, this is equal to 0. And now this is our second equation. Okay, you need to create two equations so that you can solve for the two unknowns. Okay, you need at least two equations to solve for the two unknowns. Okay, now we are going to make a or b the subject of the formula. You can use equation number 1 or equation number 2. Okay, I'm going to choose the simplest one. I can go for equation number 1 and make a or b the subject of the formula. Okay, so from 1, a is equal to negative b. When you take b to the other side, negative b, negative 3. Okay, you have to plug it into 2, into another equation. Okay, you plug into 2. So you have this into 2. You have negative 12, right? Into 2. This is 2. You have negative 12 plus 4a. A is this. This is your a. And then plus b. This is equal to 0. Okay. You have negative 12, negative 4b, negative 12, right? Negative 12 plus b. This is equal to 0. So you have negative 4b plus b, which is negative 3b, right? B minus 4b, which is negative 3b. And we have negative 12, which is negative 24. To the other side, you have positive 24. You are going to divide by negative 3 on both sides so that you can solve for b. B is equal to, when you divide by negative 3 on both sides, b is equal to negative 8. Okay, 24 by negative 3, you have negative 8. You are going to use this equation to get your a. You can use this. A is equal to negative b. B is negative 8. So you have negative 8, which is this. And then minus 3. A is equal to, this is 8. 8 minus 3, which is 5. Right? 8 minus 3, which is 5. So b is equal to negative 8 and a is equal to 5. Okay, now let's solve a problem on remainder and factor theorem. Okay, let's solve a problem on remainder and factor theorem. Okay, you are given f of x is equal to ax squared plus bx minus 4. Determine the values of a and b. If x plus 1 is a factor of f of x and the remainder is negative 6 when f of x is divided by x minus 2. Okay, so solution, you are given f of x is equal to ax squared plus bx minus 4. Determine the values of a and b if x plus 1 is a factor of f of x, right? If x plus 1 is a factor of f of x and the remainder is negative 6 when f of x is divided by x minus 2. Okay, from this, when x plus 1 is a factor of f of x, it means if you plug negative 1 in there, you're going to get the remainder equal to 0. And on this one, when you plug 2 in there, the remainder is negative 6. Okay, so when you take f of negative 1, right, f of negative 1, you are going to plug negative 1 wherever you have x. Okay, this is equal to a times x squared. X is negative 1 plus bx. x is negative 1 minus 4. This is equal to 0 because this x plus 1 is a factor of f of x. This is what you are told. Okay, you are trying to solve for the two unknowns. You need to create at least two equations. Okay, so this is what I'm trying to do. I'm trying to create two equations. Okay, so let's carry on. You have negative 1 to the power of 2, negative 1 to the power of 2, which is 1. 1 times a, it's a, plus you have b times negative 1. So you have negative b minus 4. This is equal to 0. And so this is our first equation. Okay, this is our first equation. We need to create at least two equations. This is our first equation. Let's create our second equation. You are going to plug 2. So you are going to plug 2 in there. This is going to be equal to negative 6, the remainder. Okay, remember from the previous slide, f of any x value is going to give you the remainder. And you are told that the remainder is negative 6. When you plug 2, f of 2 is equal to, you are going to plug 2 wherever you have x. So you have a times x squared. X is 2 plus bx. X is 2 minus 4. This is equal to negative 6. Okay, negative 6. Okay, let's carry on. This is 2 to the power of 2 times a. So 4a 2b plus 2b minus 4. This is equal to negative 6. Okay, so you have 4a plus 2b. When you take this to the left, negative 6 to the left, you have 6 minus 4, which is 2. So you have plus 2 is equal to, you remain with 0 on the right side. So this is our second equation. Now we have two equations. Okay, we need at least two equations to solve for the two unknowns. We are going to make a or b the subject of the formula. You can use equation number 1 or equation number 2. Okay, I'm going to choose the simplest one. I can choose 1. So from 1, a is equal to b, when you take b to the right side, plus 4. Okay, you're going to plug this into 2. Okay, so this is what we have for 2. You have 4a. Your a is b plus 4. B plus 4 plus 2b plus 2. This is equal to 0. So you have 4b plus 16 plus 2b plus 2. This is equal to 0. 4b plus 2b, which is 6b. This is equal to 16 plus 2, which is 18. To the other side, negative 18. You're going to divide by 6 on both sides so that you solve for b. By 6, you have b is equal to negative 3. Okay, negative 18 by 6 is negative 3. This is b. Now a, to get a, you are going to use this. A is equal to b plus 4. b is equal to negative 3. You have plus 4. So a is equal to 4 minus 3, which is 1. Okay, a is equal to 1, b is equal to negative 3. Now we are going to solve cubic equations. Okay, you need to know how to solve cubic equations so that you can find your x-intercept, the x-intercept of a cubic graph. So problem number 1, determine the x-intercept, or they can say determine the roots or the zeros. Whether they say x-intercept, root, or the zeros, they still want you to determine where the graph is going to cut the x-axis. Okay, determine the x-intercept of a cubic graph with equation f of x is equal to this. Solution, as always, to determine the x-intercept, you let y equal to 0. This is your y. So to determine x-intercept, let y, your y is f of x, let y equal to 0. Okay, so this is f of x. You let it equal to 0. So before that, you can multiply by -1 throughout so that you have a positive coefficient. So when you multiply by -1 throughout, you have x cubed minus 7x squared plus 15x minus 9. This is equal to, you multiply 0 by -1, you get 0. So this is what you get when you multiply this by -1 throughout. So to solve a cubic equation, you are going to solve it by trial and error. Okay, you are going to factorize it into a linear part and a quadratic part. Okay, so let's get our linear part. Okay, you are going to solve it by trial and error. Okay, you are going to plug different values of x and use any x value that makes f of x equal to 0. If you get 0, you're going to use that x value. Okay, so you can try numbers like 1, -1, 2, -2, 3, -3, 4, -4. All those numbers, you can try them and see if you get 0. Okay, let's try -1 and see if we are going to get 0. We are going to plug -1 in there and see if we are going to get 0. Okay, let me use my emulator. So I'm going to plug -1 wherever I have x. So -1 there to the power of 3 minus 7 times -1 to the power of 2 plus 15 times -1. So you are plugging -1 wherever you have x. Okay, minus 9. This is equal to -32. Okay, so this is not 0. -1 does not work. Okay, so let's try 1. Okay, we have tried -1. -1 does not give us 0. Let's try 1. We are going to plug 1 wherever we have x. So you have 1 to the power of 3 minus 7 times x squared. X is 1 plus 15 is 1 minus 9. You can see 1 is giving us 0. Okay, 1 is giving us 0. So we are going to use x is equal to 1 because 1 is giving us 0. Okay, x is equal to 1. Okay, now you are going to have this x minus 1 when you take it into the bracket from positive to negative, because when you solve for x, x is equal to 1. Okay, when you take it back into the bracket -1, you change the sign. Okay, so this is your linear part. Now let's get the quadratic part. Okay, we have to get the quadratic part. So x multiplied by what will give us x cubed. You need to multiply x by x squared so that you have x cubed. Okay, and -1 multiplied by what will give us -9. You have to multiply by plus 9. You have this. You need the middle term. To get the middle term of the quadratic part, you're going to use this, the one with x squared. I'm going to use -7x squared. Okay, from this, you can see I already have -x squared when I multiply this. So I'm going to use this term. After using this, I'm going to use this. I'm going to get what? -6x squared. Because you know when I add the 2, I'm going to get this -7x squared, right? -x squared minus 6x squared. This is equal to -7x squared. So I have to get -6x squared from this. Okay, after using this -1, I have to use this times another term in the middle there in such a way that I have -6x squared. Okay, so this times this, I have to get -6x squared. Okay, so x times what? Times -6x, right? X times -6x will give me this. Okay, so this is the middle term. You can now factorize this. So the first part is this, and this, you can factorize it like this. So you have x squared, you're going to have x times x, and you have 9. You can have 3 times 3, because from 3 and 3, you can have negative 6. Okay, so 3 and 3, so you have negative day. Okay, the signs are going to be the same because you have positive day. Same as what? As negative. So negative. So x is equal to 1 or x is equal to 3, right? X is equal to 1, x is equal to 3. You can try to sketch this graph. You are going to see that you have an x-intercept at 1 and an x-intercept at 3 and a turning point at 3 on the x-axis. So we're still solving problems on cubic equations. Okay, now question 2. Determine the x-intercept or determine the roots or zeros. Okay, they still mean x-intercept. Okay, determine the x-intercept of a cubic graph with equation f of x is equal to negative x cubed plus x squared plus x plus 2. Okay, so solution: to get the x-intercept, you let y equal to 0. Okay, to get the x-intercept, you let y equal to 0. Okay, so this is y. You let it equal to 0 so that you can get your x-intercept. So you are going to multiply by negative 1 throughout so that you have a positive coefficient. So you multiply by negative 1 throughout, you have x cubed minus x squared minus x minus 2 is equal to 0. Now, you are going to plug different values of x and use any x value that makes f of x equal to 0. You have to get a linear part and a quadratic part. The linear part, you are going to get it by trial and error. So you have to plug different values of x and use any x value. You use the x value that makes f of x equal to 0. You can try numbers like 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, and so on. Okay, you can try those numbers and see which one makes f of x equal to 0. So let's try 1. Okay, I'm going to plug 1 wherever I have x. Okay, so I'm going to plug 1 wherever I have x. So I have 1 to the power of 3 minus 1 to the power of 2. You plug 1 wherever you have x. I have minus x. X is 1. Minus 2. This gives me negative 3. Okay, not 0. I have to get 0. So 1 gives me negative 3. Okay, so 1 is not going to work. Let me try negative 1. So I'm going to plug negative 1 wherever I have x. So let me change this. Now negative 1. And see if I'm going to get 0. Negative 1. I still don't have 0. I have negative 3. Okay, let me try negative 2. Okay, negative 2. So I'm trying to plug different values of x and see if I get 0. Now, with negative 2, I get negative 12, not 0. So negative 2 is not going to work because I don't have 0. I have negative 12. Okay, let me try 2. So let me remove the negative. I want to try 2. So 2 works. 2 gives me 0. Okay, I'm going to use x is equal to 2 because 2 gives me 0. Okay, so the linear part is x minus 2. When you take this in the bracket, the sign change from positive to negative. Okay, you have to change the sign because when you are going to solve it, you're going to have x is equal to 2. Okay, now we have to get the quadratic part. Okay, so x times what will give me x cubed. X times x squared will give me x cubed. Negative 2 times what will give me negative 2. Okay, negative 2 times plus 1. Negative 2 times 1 will give me this. Okay, now I need the middle term. Okay, I'm going to look at this, the one with x squared. Okay, negative 1x squared. Okay, so from this, you already have negative 2x squared. Okay, you already have negative 2x squared. So you are going to add what? What do you need to add to this so that you have negative 1x squared? You're going to add plus x squared. This is going to give you negative 1x squared. Okay, you're going to get this. So you need to get this term from this and the middle term. So you have this times another middle term. You have to get this. So you have x times what will give you x squared, right? Plus x squared. You have to multiply this x by another term in such a way you have plus x squared. So you have x times what? Plus x. X times plus x, you're going to get plus x squared. So this is what you have. You have this. From this, x is equal to 2, and this cannot be factorized. So this quadratic part has got no real solution. Okay? So no real solution for the quadratic part. You can try to use the quadratic formula. You're going to see that you have no real solution for this part. So when you try to sketch this graph, you're going to have a graph cutting the x-axis only at one point on the x-axis, which is 2. Now question 3, we're still solving cubic equations. Okay, now question 3. Determine the x-intercept or determine the roots or determine the zeros, right? Determine the x-intercept of a cubic graph with equation f of x is equal to this. Solution. So to get the x-intercept, you let y, your y is f of x. To get the x-intercept, you let y equal to 0, as always. Okay, so this is your f of x or your y. You let it equal to 0 so that you can solve for the x-intercept. You have to try to solve by trial and error. Okay, you are going to plug different values of x and use any x value that makes f of x equal to 0. So we are going to try to plug numbers like negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, and so on, and see if we are going to get 0 and use the number that gives us 0. Okay, let's try negative 1. We are going to plug negative 1 in there. So you have negative 1 to the power of 3, which is negative 1, plus 13 plus 12, which is 24. You can see you don't get 0. So let's try 1. Okay, negative 1 does not work. If you plug 1, you're going to have 1 there, which is negative 13, and 1 there to the power of 3. So 1 minus 13, which is minus 12, plus 12, which is 0. So 1 can work. So we are going to use x is equal to 1. So our linear part is x minus 1. Okay, x minus 1. When you bring this in the bracket, you have x minus 1. And the quadratic part, let's get the quadratic part. So x times x squared, I'm going to get x cubed. Negative 1 times negative 12, I'm going to get positive 12. Now, let's get the middle term. So, I'm going to look at x squared always. But you can see, do I have x squared? Yes, I have x squared after x cubed. There is 0x squared after x cubed. Okay, so I have from this, I have negative x squared when I multiply the two. I have to get plus x squared. This is going to give me 0x squared. Okay, so this x squared is going to be from this times another term. So I have to get x squared, so which is plus x. Okay, so I have this, and from this, when I factorize, I've got x squared. I'm going to have x times x. And from this, I can use 3 times 4. 3 times 4 is 12. And from 4 minus 3, I've got 1. So I can have 3 there and 4. I'm going to have minus there and plus there. Okay, so x is equal to 1, or x is equal to 3, or x is equal to minus 4. Okay, so if you sketch this graph on a Cartesian plane, you are going to have your x-intercept at 1, at 3, and at negative 4. We're still solving problems on cubic equations. Okay, now it's question 4. Determine the x-intercept, or determine the roots, or determine the zeros of a cubic graph with equation f of x is equal to this. Okay, so solution, as always, to determine the x-intercept, you let y equal to 0. Your y is f of x. Okay, so you let f of x equal to 0, right? Before you can carry on, you have to notice that x is common in all the terms. Okay, what you are going to do is to factorize x outside of the bracket. You have x times x squared. You're going to get this minus 10x. When you multiply, you're going to get this plus 25. When you multiply, you're going to get this. Okay, this is equal to 0. So you take x outside of the bracket. Okay, so you have x. You are going to factorize this. Okay, so you have x squared. You are going to have x times x. You have 25. You know that 5 times 5 is 25. And from negative 5 minus 5, you have negative 10. So you are going to have 5, 5. Okay, negative and negative. So you have x is equal to 0. Right? X is equal to 0, or x is equal to 5. Okay, x is equal to 5. X is equal to 5. Okay, so when you sketch this graph, you are going to have an x-intercept at 0 and an x-intercept at 5. And again, you are going to have the turning point at 5 on the x-axis. Okay, a turning point on the x-axis at 5. So this is how you can solve this question. Let's move on to question 5, the last question. We're still solving cubic equations. Question 5, determine the x-intercept, or determine the roots, or determine the zeros of a cubic graph with equation f of x is equal to this. Okay, solution, determine the x-intercept of a cubic graph with equation f of x is equal to 2x cubed minus 7x squared plus 9. To get the x-intercept, you let y equal to 0. So you have this. This is your y. You let y equal to 0 so that you can solve for the x-intercept. Okay, you are going to factorize this into a linear and a quadratic part. Okay, so the linear part, we are going to find it by trial and error. You are going to plug different values of x and use the x value that gives you 0. Okay, that makes f of x equal to 0. So let's try 1 and then negative 1 and 2, negative 2, 3, negative 3. Okay, we are going to use the one that gives us 0. That makes f of x equal to 0. Okay, so let me use my emulator quickly. So let me use negative 1. I'm going to plug negative 1 wherever I have x. So negative 1 wherever I have x. I hope you can see that. Negative 1 wherever I have x. So this works. Negative 1 works. Okay, so I'm going to use x is equal to negative 1. Okay, you should try 1. Can 1 work? So let me remove the negative. 1 doesn't work because you don't have 0. You have 4. You have to get 0. To find the x-intercept, let y equal to 0. So you have to get the x value that makes f of x equal to 0. So negative 1 makes f of x equal to 0. So we have to use negative 1. Okay, not 1, because 1 gives you 4. So negative 1 makes f of x equal to 0. So now we are going to have like this. X, remember, when you take it into the bracket, it's plus 1. Okay, because if you solve for this, you are going to have x is equal to -1. So this is the linear part. Now the quadratic part. Right? Remember, a cubic equation can be factorized into a linear and a quadratic part. This is our linear part. Now let's get our quadratic part. Okay, so you have x. X times what? You're going to get 2x cubed. So you need 2x squared. Right? You have 1 times what? You have to get 9. So 1 times 9. So plus 9. When you multiply the 2, you get this. Okay? If you multiply this and this, you get this, and this, you get this. Now, let's look at our middle term. We have to get our middle term, negative 7x squared. You already have 2x squared there, right? You need to have negative 7x squared. So you are going to subtract negative 9x squared. This is equal to negative 7x squared. Okay, so you have to get negative 9x squared from this multiplied by another middle term. So you have to multiply x by the middle term in the quadratic part in such a way that you have negative 9x squared. Okay, so you are going to multiply x by negative 9x. When you multiply this and this, you get this. Okay, so this is what you have. Now you are going to factorize this. You have this. You are going to factorize this. Right? This part, the quadratic part. So you can have 2x times x, right? Get this. And from this 9, you can have 3 times 3, right? Let's see. 3 times 3 is 9. So can you get the middle term? This is 6x and this is 3x. Okay, 6x, 3x. So you have negative 6x, negative 3x. You have this. So you must have negative, so that you have this. Okay, you can even see you have positive. When you have positive, it means the signs inside the bracket are going to be the same. The same as what? The same as negative. Okay, negative, the same signs. Okay, now from this, x is equal to negative 1, or x is equal to 3 over 2, right? Or x is equal to 3. Okay, so this is how you can solve this question. When you sketch this graph, you're going to see that your x-intercepts are at negative 1, at 3 over 2, and at 3. Okay, 3 over 2 is 1.5. Okay, you can try to sketch this graph on the Cartesian plane. You're going to have your x-intercept at negative 1, at 3 over 2, and at 3. Okay, so we are done with lesson 3 of 6. Please check for lesson 4 of 6. Okay, until next time, I will talk to you soon.